Hi, and welcome to the 10 square metre workshop. Woodworkers, this is going to be something you want. No, this is something you're going to really want. So carry on watching at your own peril. Okay, you still here? Imagine a router table where you never need one of these again, or a ruler, or any other sort of measuring equipment. Just say where you want the bit, where you want the fence, and it goes there, time after time, to an accuracy of 0.01 millimeters. Good enough? Right, not just that. Imagine you want to make a box joint with fingers. Let's say you want a 6mm finger and you've only got a 5mm bit. No problem. Tell it that and it will automatically move to the right position. Make your cut, press a button, moves to the next position. No measuring required. You can just throw these away. And here is the beast, the Route Master. Now yes, you can buy these things commercially, but they'll set you back about £2 grand. Not so keen, eh? But you can make this for a fraction of that money. And there's no doubt about whether it'll fit your table, because you make it to fit. It's all driven by this touchscreen display. All the features are there and it tells you exactly where everything is. Want to go to a particular position? Just go into manual. Select where you want your bit, let's say 12mm. And where you want the fence, let's say 10mm. And then say go. First the bit comes up, and then the fence moves, and there you are. Just for fun, let's do the coin test. Impressive, isn't it? This build falls pretty naturally into 3 parts. The router lift, the fence and the control system, although there'll be a little overlap. So I shall start off with how I motorised my router. Taken out of the table, this is the underneath of my router bench. This is the scale, which measures the height. This is where the winder attaches normally, and this is a hand wheel, and that's where I'm going to fit the motor. I shall be using this geared 12-volt motor from a previous project, originally from Amazon, for the drive. I shall be using this old box spanner to make a coupling. I then made a brass plug and tapped it home, and fitting a small rivet to make sure it stays put. Then into the lathe to be bored out 8mm for the motor shaft. Then drilled and tapped 4mm for the securing grub screw. I'm now in a position to test if the motor has enough power to turn it. Yes, smooth and easy, and that's on 8 volts for a 12-volt motor. No problems there then. Just need to mount the motor. Nothing particularly complicated needed here. It just needs something to stop it turning or falling off. Otherwise it can locate on the spigot itself. So I'm going to put one screw through the casing. And here's hoping there's nothing behind it. Yes, I could disassemble it to see what's there, but I'm going to take a chance. Wish me luck. Turns out there's a lot of free space behind there. So here's the bracket mounted. Time to give it a try. Once again I'll try it on 8 volts to make sure I have plenty of headroom. Yes, very smooth. My original plan was to drive the bit height via a bridge amplifier such as this. I even built the circuit. Then it dawned on me, this is never going to be a servo amp. There's far too much backlash for that. Instead, the idea is if you're above, drive to below, then come up to the value, slowing down as you approach it, the way a machinist would do it. This means a relay is perfectly appropriate. Gives better drive and a much simpler circuit. Final step on the router part is to fit a small micro switch like this to detect when the router is in the fully up position. Fully up in the Triton router that I'm using locks the spindle for easy bit change, and it's important to be able to detect that. And that concludes the steps needed to motorise a suitable router. And if it seems rather simple and straightforward, well, that's because it is. Fitting the DRO, if you're interested, I did a separate video on. Check it out. So that's the router lift working. But of course you need a power supply to drive the motor, so I shall cover a little of that in this episode. I actually need 3 power supplies, 24 volts for the stepper motor, 12 volts for the bit drive motor, and 5 volts for the logic. I could of course use a 24 volt motor for the router, but I'm too mean to buy another motor. For the power supply interface box, I cut out this piece of aluminium. This was put in my scratch built folding frame for bending. Three more folds, and I have the basic chassis made. After making sure it fits in the space, kind of important, I start laying out the modules into the chassis. With everything mounted in the case, it's now time to wire up. With the router lift now working in a satisfactory manner, I shall leave it to the next time to start describing how the fence is made. Hope to see you then.